This is video number 2, inverses of a function. So again, take notes on everything that I'm highlighting and writing down. All right, the inverse of a function. You guys should have covered this again in Algebra 2, which is why I'm doing it as a video, so we can just review it real quick. It's often necessary to undo a mathematical process. This is called an inverse operation, right? So if something's x plus 2 equals 6, for example, you probably know x is 4, but mathematically the way we can prove it is by saying we have to move this 2 over by doing the inverse, by subtracting, right? And then x equals 4 would be our answer. So that's a really simplified version of an inverse operation, but that's what they mean by that. We denote the inverse of a function with this notation right here. So definitely write that down. That's very important, okay? So function and its inverse notation. All right, and then it says, note, f of negative 1x does not mean 1 over f of x. So be careful. It's not this, you guys. If it was this, then that would mean that, all right? But it's just saying the inverse function. Notice that that negative 1 is with the f, so it's not an exponent. It's just notation. That's all it is, okay? All right, so let's do 132 together. Consider the function f of x equals 1/2 x plus 6. What steps are necessary to undo the function? So we need to look at it and say, well, what is happening? I need to get x by itself. So I would need to minus the 6, right? And I would need to, if it's divided by 2, 1/2, I would multiply by 2 to get rid of that 1/2, right? And then that's it. That should be those steps to undo it. Use these steps to find an expression for the inverse of x. So I did all the steps for you here on B. So remember that f of x equals y. So right here, I put a y in. And then for the inverse, you guys, we actually want to switch the x and the y value. So this last step right here, I would actually say y equals 2 times x minus 6. And that would be my true inverse, right? So let me get rid of the y, sorry. And sorry about that, guys. I'm going to write that as f of x negative, right? Negative 1. So that shows me that this is actually my true inverse equation right here. All right, so make sure you write all of that down. Okay. Next, we going to do operations with functions. So I think you guys saw these in Algebra 2 before. It's composite functions and then sums and differences and quotients and products. So operations with functions, we're just going to take two different functions and we're going to add them, subtract them, divide them, and multiply them, right? So make sure you write all of these down. This is really important. And you probably want to pause the video at this point so you can jot that down really well. So the title of it should be Operations with Functions right there. And then write each of them down exactly as they appear. A product can also be written as f of g of x or just f times g. So make sure to include that little gem in product right here at the bottom, right? So we could also write it like that. Okay, we can also compose functions. So write that down as well. Compose functions. This means that the output of one function becomes the input of another function. In other words, you're going to solve it twice. The first answer you're going to plug into the second equation. So go ahead and write it down, and then don't worry, we're going to do some examples of these, okay? So it's saying hold on, guys. If f of x equals 2x minus 1, and g of x equals x squared, then if I'm looking at f of g of x, that means, let me color code for you here, I'm going to take g of x, which is my x squared, right? That's the most inside. And I'm going to plug that into f of x in x's spot, right? So I'm going to take that to x minus 1, right, from my f of x right here. And instead of x, I'm going to put in whatever g of x's equation was. So in this case, g of x was just x squared. So I would put that right there. And that would be it. You're done. You can't solve anything because you didn't have a number to plug in, right? And then on the second one, you're just doing the reverse. So you're taking the f of x is the most inside, right? That's g of f of x. So f of x is 2x minus 1. G of x is just x squared. So instead of x squared, we're going to do 2x minus 1 and then squared because that is g of x, okay? So don't worry, I'll do a couple examples in a second. Another way to write compositions of functions other than f of g of x, if you look down here, is like this. They'll do an open dot. So just be careful. That does not mean multiplication. It's not the same as this up here. Okay, so notice that's just a regular old closed dot, and the f and g are also together, right? So both of these are our composite notation. Okay, so composite functions are done like that. All right, let me do a couple examples for you guys now. All right, so here's a good example. Given f of x equals 3x minus 5, so I'm going to make that orange. That's my f, right? And g of x, I'm going to make this one purple, is x squared plus 2. Find and simplify the following expressions. So when we're adding, you guys, we just straight up add them together, right? So f of x is 3x minus 5 plus g of x, which is x squared plus 2. And then you're literally just simplifying this expression, right? You're just combining like terms. I'm going to hesitate to put an equal sign since it's not an equation, right? So when I combine my like terms, I'm just going to make this blue to be neutral. I have only one x squared. I have only a 3x. And then I have a negative 5 and a positive 2, which would combine to give me negative 3. And then that's it. Simplify, notice it says, not solve, right? So that's all we can do. And then f of x times g of x. So that's just straight up multiplication, right? I'm going to put it in parentheses since there's two terms. And then when I multiply it times g of x, I'm going to need to do a little bit of foiling here, right? So my first term is going to be, make this one blue also, is going to be 3x times x squared. So that's 3x to the third. Then 3x times 2, which is 6x. Then negative 5 times x squared, negative 5x squared. And negative 5 times 2, negative 10. Now you have no like terms here. The only way you can make it a little prettier is switch the places of these two, right, so that it was in descending order. But honestly, on this example, I don't really care. So there we go. All right, that's it. The last, or letter C, you have f of g of x. So now this is one of your composite functions. So I'm going to move this down a little bit so that I can have a little more space. So we want to look at what's on the inside. So g of x is on the inside. So that means I'm going to actually start with g of x, right? So that's going to be what I do first. And I'm going to plug that in to f of x, right? So I'm going to take my orange equation, which is 3x minus 5. Instead of x, I'm going to substitute g of x into it. So g of x was x squared plus 2, right? So I'm just replacing, instead of just a number or an x, I'm replacing this whole quantity into the orange equation. Okay, and then simplify as usual, like the others. Okay, so I'm going to keep this purple. So I'm going to distribute my 3. That's going to be 3x squared. Distribute my 3 to my 2. That's 6 minus 5. And then the final answer for that simplified expression would be 3x squared plus 1. And that's it. The next one is the reverse. So I'm going to take my f of x, which is my orange one, and I'm going to plug it in to the purple one, right? Sorry about all the crisscrossies going on. Hopefully you're following. You can always pause it, rewind if you need to watch it again, right? So I'm going to take my purple equation, which is my x squared, my g of x, plus 2. But remember, instead of x, you guys, right? Oh, whoops. Ha! I forgot I hid that stuff under there. Instead of x, I'm going to have my f of x equation, which is 3x minus 5. So I'm going to be squaring that, right? And then I'm just going to simplify. So remember, this one right here, guys, is a quantity squared. When we have a quantity squared, we square the first term, we multiply them together, which is negative 15x, and double it, so that would be negative 30x. and then we square the last term, so plus 25. If you do not believe me, please feel free to write it twice, like this, and FOIL it to your little heart's content, right? And you should definitely get 9x squared minus 30x plus 25. Just make sure you don't get 9x squared plus 25 and forget that middle term. That's a really common mistake, and you guys have to stop doing that because now you're advanced mathematicians. Yay. All right, so from here, we just simplify. The only thing we can do is combine the 25 and the 2, right? So my final answer is going to be 9x squared minus 30x plus 27, and that is the expression that's the composite function of g of f of x. Okay, so I hope that this is good for you guys. Take good notes and let me know if you have any questions.